So number 15, you have y equals x squared plus 16 minus 8x. And on this one, you're supposed to determine what are the x-intercepts and whether its vertex is above, below, or on the x-axis. And so remember, the way this works is there are really three options for any parabola. You can have the vertex above the x-axis. This is for parabolas that are opening up, which this one's opening up, by the way, because we have a positive x squared term. If the x squared term is negative, then it opens down, and so it's positive, so this one's opening up. So that would be no x-intercepts. You can have it resting on the x-axis, which means you have exactly one x-intercept, and then you can have below the x-axis, which means you'd have two x-intercepts. And all of these can be determined by the discriminant. If the discriminant is negative, then that is this case. If the discriminant equals 0, that's the case where it's resting on the x-axis and has exactly one solution. And then if it's anything else, then it's below, which means you have two x-intercepts. So for number 15, we do the discriminant. Remember, the discriminant is negative b squared minus 4ac. And so that's going to give you negative 8 squared minus 4 times 1 times 16. So remember, we would rewrite this as x squared minus 8x plus 16. So a is 1, b is negative 8, and c is 16. So that gives me 64 minus 64, which equals 0. So our discriminant on this one is 0. And whenever your discriminant is 0, that means you have one x-intercept. And it means the vertex is on the x-axis. And so it's not below or above, it's actually on the x-axis for the vertex. For number 19, you're given that find k so that the solution of 9x squared plus 12x plus k equals 0 has one real, what we call double root. Well, this happens in the same instance that we had for number 15, which is when the discriminant equals 0. When the discriminant is positive, you have two real roots. When the discriminant is 0, you have one real root. When the discriminant is negative, you have no real roots. So if the discriminant is positive, if we want one root, we need it to equal 0. So we calculate the discriminant. So it's going to be b squared, so 12 squared, minus 4 times a, which is 9, times k, which is c. And we want to find out when does that equal 0 because we want the one root. So that's going to happen when you get 144 minus 36k equals 0. So you can solve that. So 144 equals 36k. So when you divide both sides by 36, you get k equals 4. So when k equals 4, you get 9x squared plus 12x plus 4 equals 0. Now, the reason why that works is because that factors to 3x plus 2 squared equals 0. So my only solution for this one is negative 2/3, and it's a double root because you have this perfect square that was there.